Well, hello there. We're going to do a little video today, and I'm going to talk through how to use the factor label method. And that's just a procedure for dealing with labels in calculations. We're going to do examples where we're doing unit conversions, but certainly the factor label method falls into all sorts of areas more than just unit conversions. There just happen to be a simple type of exercise for us to practice on. So, I have some steps here. What I'm going to suggest, I'm going to read through these, and then I would suggest that you just pause the video and make sure that you get these down. Number one, write the given. Some piece of information, some quantity was given you in the problem. In your workspace, write it down. Step two, multiply by a conversion factor such that we can cancel a label. I will define conversion factors in just a little bit. Step three, we're going to string together more conversion factors until you're finally left with an answer that has the correct labels. We can do as many conversion factors as we want. And then step four, once we have it all labeled, laid out and the labels work, we're going to go ahead and do the math. The math is going to be multiply by any numbers that are on top of the fraction line and then divide by any numbers that are on the bottom of the fraction line. So I would suggest that you pause the video, make sure you have those steps written down, and then resume playing. So let's look at an example problem. Number one, we're going to convert 12.5 miles into feet. Okay? Step one, write down the given. So my work area, I got 12.5 miles. Step two, it says multiply by a conversion factor such that we can cancel a label. So let's check now. What is a conversion factor? A conversion factor is a ratio made from any unit relationship we know to be true. Any relationship that I know to be true. For example, we know that 5,280 feet equals 1 mile. That's the definition of a mile. And so what ratios can I make? Well, I can either put 5,280 feet over 1 mile, or I can put 1 mile over 5,280 feet. Both of those are conversion factors, and they can be used in problems. If you look at it mathematically, remember anytime you divide something by itself, it has a value of 1. That's important. The number that's on top, the measurement, I should say, on top, and the measurement on the bottom are exactly the same distance. So therefore, this ratio has a value of 1. And it's not going to actually affect the math of our problems. It's just going to change the labels. Where do I find conversion factors? Well, yesterday we went through a set of English relationships that I want all of you to know. You know, things like 12 inches in a foot, 5,280 feet in a mile, 16 ounces in a pound, 4 quarts in a gallon. You already know those, or you should. You can look up references, like your planner. Your planner has some references. But quite often, I'll give you a few relationships on your assignments and quizzes to use. So between what you already know and a couple of relationships that I give you, we should be pretty set. So, remember, if I got miles and feet, I know that there's 5,280 feet in a mile. So I can put either 5,280 feet over 1 mile, or I can put 1 mile over 5,280 feet. And this is where we get to the part by such that we can cancel a label. See, if I put 5,280 feet over 1 mile, this fraction line goes through here, and essentially miles were in the numerator here, and miles were in the denominator here. So anytime I have the same thing top and bottom, I can cross them off. Miles cross off, right now, the only label that I have on this problem is feet. And that's what I'm looking for. All right, so if that's what I'm looking for, step 3 where it says string together more conversion factors, I don't have to. I'm already at the label I'm looking for. Step 4 says do the math. Well, my math says take 12.5, because that's my starting quantity, multiply by 5,280, and then this line right here means division. But in this case, we're dividing by 1. I really could skip that step. I don't have to punch that into my calculator. But when all is said and done, I see that I have a value of 66,000 feet. 12.5 miles is 66,000 feet. There's our first example. And this is a factor label method setup. We're setting things up so that we look at our labels. Every time we write down a quantity that's a measurement, it has to have a label with it, and we have to do math with that. All right, so how about if I want to change 12.5 pints into gallons? So my starting point is 12.5 pints, okay? And it says multiply by a conversion factor. Do I know how many pints are in a gallon? Well, I've got enough practice that I do probably know that, but let's just imagine we didn't. It wasn't on the list that I gave you to know. So if I don't know how many pints are in a gallon, here's what I do. What do you know about pints? Well, we hopefully know that 2 pints is 1 quart, and 2 cups is 1 pint. Those were the 2 things that were on the list that I told you were supposed to know. Which of these is going to help us? Well, I'm hoping with some past experience, you know that at least going to quarts would be going closer to gallons. Okay, gallons are bigger than pints. So if we go from pints to quarts, we're getting a little bit bigger. We're going to think about what might happen next. These are my 2 choices. I'm going to use this top one. Now it says multiply a conversion factor such that labels cross off. So this part had pints in it. I have to keep the whole thing. It's 2 pints. 1 quart over 2 pints. Because the top has to equal the bottom on my conversion factor. That way this has a value of 1 and it's not changing my value. If I do that much, I can cross off pints. Okay? But now, this is taking me to quarts. I didn't want quarts, I wanted gallons. So this is where that step 3 comes in. We can just string together more conversion factors. Say, do I know anything about quarts in a gallon? There's 4 quarts in a gallon. And I want quarts to cross off, so I'm going to put the 4 quarts on the bottom. And the 1 gallon goes on top. And check my labels, quarts cross off. Check my labels, I'm left with gallons, and that's what I wanted to find. So I'm done doing conversion factors. Now I do the math. And my math says take 12.5 times 1 divided by 2 times 1 divided by 4. I would really encourage you to try to use that ordered thinking for doing your math. Could I take 12.5 times 1 times 1 divided by 2 times 4? Not quite. If I put the 2 times 4 in parentheses, I could do that. But if you take this times this times this divided by 2 times 4, you will get a wrong answer. You have to put that in parentheses. Or what I do is divide by 2, divide by 4. Because these are both on the bottom. I've got to divide both times. I would usually skip the ones. I don't punch that into my calculator. So my math that I would type in, I'm going to take 12.5 divided by 2 divide again by 4. And if I do that, you know what? I need a calculator handy. Okay, 12.5 divided by 2 divided by 4 equals 1.56 gallons. There was a little bit more. We will talk about rounding rules in just a day or two. Right now, 3 or 4 digits is fine. All right, let's make it a little bit more tricky. We're going to go 55 miles per hour into feet per second. So now we got a quantity. This is a speed, and speed has both length and time, or distance and time labels in it. It's got 2 labels. When I write down my beginning quantity, 55 miles per hour. Well, that's not wrong, but if we want to make things easy for yourselves, we're going to do that a little bit differently. Instead of writing it down like that, I'm going to write 55 miles per hour. That's a fraction. And what it's really saying is you're traveling 55 miles in per 1 hour. So I don't have to write the 1 there. I could write the 1. But I want to make sure when we're doing our math that I know that miles are in the top and hours are in the bottom. Multiply by a conversion factor. Let's see. Well, I don't know how many miles per hour are in a feet per second. I don't know that relationship. What I can do is break this apart. I can take it in pieces. Just like I went from pints to gallons by going by way of quarts, I can do this in pieces. And in this case, I'm going to look at my length label. I got miles and feet. And I know there's 5,280 feet in a mile. And that mile is on top, so I want mile on the bottom. There's 5,280 feet in 1 mile. I'm going to put another conversion factor. This one is going to cross off miles. Hours and seconds. Well, you might be able to do the math in your head and figure out how many seconds are an hour, but if you're unsure, let's break it down. What do we know goes into? I know in 1 hour there's 60 minutes. So if I did that, I could cross off hours. Now look, hour was on the bottom. So even though it's separated a little bit, I want hours on the top. I always want to be able to cross off a label. That's key. Every conversion factor, I want top to equal bottom and cross off a label. If I do that, I may not always know how to finish a problem, but I will never screw it up to the point where I can't get it right. So long as the top equals the bottom and I can cross off a label. Okay, what next? Well, this would be feet per minute. I want feet per second. So let's do another conversion factor. Minutes. Well, 1 minute, so I put it opposite, is 60 seconds. If I do that, I can cross off minutes. What does my math look like? It looks like 55 times 5,280 divided by 60, divide again by 60. I'm going to punch that into the calculator. 55 times 5280 divided by 60, divide again by 60 equals 80.7 feet per second. Okay? Now, I sincerely hope that as I'm doing practice problems, you have a calculator and you are punching these in too to make sure that you're getting the same thing. Because if you're not getting the same thing, you're making a math error somewhere. Okay? Now, I want to show a little variation. Because this is all well and good, but there's just a simple organizational aid for doing math problems when we have just lots of steps and lots of labels to keep track, and we're multiplying and dividing. It's just a variation on this. Basically, if you just imagine that where my fraction line is, I just draw one long work line. And every one of these conversion factors, where I'm multiplying conversion factors, we just separate them with a vertical bar. And it's just a nice way of organizing things. And I will certainly be using that a lot, so I want you guys to be familiar with it. I just keep going, as many conversion factors as I need. Whatever conversion factor I have, top equals bottom, cross off a label. Top equals bottom, cross off a label. Top equals bottom, cross off a label. Okay, so let's try another exercise. All right, so this one says convert 0.053 kilograms to decigrams. Well, I hope that you recognize right off that kilogram is a metric label and decigram is a metric label. And so we said yesterday that if you were doing metric conversions, we just have to figure out how far to slide our decimal point. So what I might do is, think about my little chart: kilo, hecto, deca, base, deci, centi, mil. We're starting with kilo. We're trying to get to deci. So I've got to go 1, 2, 3, 4 columns over. I'm going to take my decimal point. I'm going to move it 1, 2, 3, 4. I'm going to need a 0 to hold that spot. And so I just find out that I've got 530 decigrams. Okay? There are times where it's beneficial if we can figure out a conversion factor to use. In particular, if you're doing a bunch of math and you've got English labels that you have to convert, and you also need to do some metric at the same time. So how would we get a conversion factor for this? Well, let's do a factor label setup. If I were doing this as a factor label method problem, I'd write down my given, kilograms, and then I multiply by a conversion factor. Within the metric system, remember, all the units are related by powers of 10. So I just have to look at this and figure out what my relationship is. And so of these two labels, kilo and deci, I know kilo is the bigger one. And so what I like to do is start with the bigger unit and just imagine if I had 1 kilogram, well, that would be equal to 10 hectograms. That could be a conversion factor. One of these equals 10 of these. It would be 100 of these. It would be 1,000 of these. And 1 kilogram is equal to 10,000 decigrams. Just from looking at this. 1, 10, 100, 1,000, 10,000. 1 kilogram is 10,000 decigrams. So I can use that as a conversion factor. I can go 1 kilogram is 10,000 decigrams. By the way, don't use commas. Use a little space to separate. We have one student here from Europe, and she can tell you that most of the world where we use a decimal point uses a comma. So when we put commas in numbers like this, it's confusing to a whole bunch of people. So you just separate 10,000, you put a little space. Use 3 digits, space, the next digits. All right, so if this works out, if I punch this into a calculator, boy, I hope I get the same answer I had up here. So I got 0.053 times 10,000 equals 530. Okay, so I can, with metric system, build in some of those. All right, I want to try to get to one more example yet on this video. I just recently saw that a USA shot putter set a new indoor world record with a put of 22.82 meters. Now, being from the United States, I just don't have a great concept of what that distance looks like. So I'd like to have it in feet. So what do? Well, we always start out with our given, 22.82 meters. I'm going to draw a work line. Meters to feet. I have an English unit and a metric unit. I'm starting with a metric and I'm trying to go to an English. And so yesterday I tried to preview this a little bit, where we have English land and metric land separated by the raging river. And so on the metric side, I have meters, and I can relate meters to kilometers, centimeters, decameters, hectare. I can relate any metric unit because they're all powers of 10. And on the English side, I could relate feet to inches, and feet to yards, and feet to miles, and yards to miles, and inches to miles, and inches to yards. I can relate all these. I know there's 12 inches in a foot. I know there's 3 feet in a yard. I know there's 5,280 feet in a mile. I know there's 36 inches in a yard. Okay? So what I need is a bridge across the river. And I only have a couple of bridges that I've committed to memory. One of them I know is that 1 inch equals 2.54 centimeters. That's a relationship between an English unit and a metric unit. Now, if you think about the problem we have right now, we're starting out with meters. How am I, and we want to get to feet. Well, here's my bridge. I have a bridge that goes from centimeters to inches. So the question is, can I go from meters to centimeters? Well, sure I can. I can do any metric conversion. I know there's 100 centimeters in a meter, and if I don't know that off the top of my head, I can draw out a little chart and figure that out. Can I go from inches to feet? Well, sure I can. I know that there's 12 inches in a foot. So I've just figured out that I've got a 3-step process that I'm going to do. So let's go back to our page. Let's write this in. All right, I said I want to go from meters to centimeters. Kilo, hecto, deca, base, deci, centi, milli. Meter is a base unit, centi is over here. 1 meter is going to be 10 decimeters, 100 centimeters. Now, I hope actually that you remember that there's 100 centimeters in a meter. And if you don't, work on it. Learn it. 1 meter is 100 centimeters. Okay? So, meters are gone. What's next? The bridge was centimeters to inches. I said 1 inch equals 2.54 centimeters. So that's centimeters on top. I'm going to put 2.54 centimeters on the bottom, 1 inch on top. I can cross off centimeters. Okay? Now I'm in inches. How do I get to feet? Well, there's 12 inches in 1 foot. Top equals bottom. I can cross off a label. And we're now in feet. That's what I was looking for. So I'm going to take 22.82 times 100 divided by 2.54 divided by 12 equals. This is 74.87 feet. Now, 0.87, we don't usually do feet in decimals, right? So we'd have a little bit more work to do. We'd have to convert to inches. But at least I know it's better than less than 75 feet, over 74 feet, over 74 3/4, so 3/4 of a foot is 9 inches, so this is probably about 74.10-ish, right? So at least I have a better concept of that than I would of that one, and I did a conversion to get there. So with this, you certainly may have to go back and re-watch some things, practice with it. I'm going to be asking you to do practice exercises, and basically I want you to do 2 or 3 practice exercises and then check your answers against the key. Do a couple more practice exercises, check your answers against the key. If you're finding that you're working against the key, that your answers aren't coming out, I would suggest that you send me an email, and I have some work time during the day. I'll be trying to check that email once in a while, and I can try to help you out. All right? But you need to practice. So that's it. Hopefully this video didn't end up going too terribly long. Enjoy your long weekend. Make sure you're doing about an hour worth of chemistry today.